Hello, welcome to this Box 42 Studios tutorial where I'll go through adding custom particle effects or PFX, or as most people know them as visual effects, to Planetary Annihilation Titans. Now this is the first in a series of tutorials I'm hoping to do, including adding custom sound effects, custom terrain, and also a custom unit to the game from start to finish, so modeling, texturing, rigging, animation, etc. I may also release other tutorials as well, but for now those are the main ones I've planned from my memory. And you can either find these here on my channel when I release them, or on my Discord. I'll also post them there with documentation, which you can find below as well, or my Patreon, and all this should be linked below in the socials section of the video description. Now without further ado, let's begin. Okay, so before I dive into the tutorial too much, I'm just going to go through the general structure. So I'll first of all go through this document and some other documentation and just the basics, and then I'll highlight not everything in the document, and then we'll move on to actually making your own PFX or visual effects from essentially scratch. And you should be able to see that I have timestamped the video, so you should be able to just click to the hopefully relevant bit that you want to. Anyway, to the documentation in front of me. So I've gone through, lately I've been doing a lot of PFX for my mod, Total Annihilation Origins, which is adding Total Annihilation to Planetary Annihilation in the game, essentially. And it's planned to be a whole overhaul, but that's obviously a different story. Anyway, lately I've been doing visual effects. I thought now is as good a time as ever to make some documentation on it to help out everyone in the community. So, as I said, this is just essentially a run through of what I deem as the essentials. But what I will say before I start fully is that there is some more documentation. So I say at the very top here, if you want a fully comprehensive glossary, then I highly recommend checking out this public document here, which I believe it was Dom from the community who linked it to me. Yep, Dom314, and you can see there's some accreditation here at the top, and it just runs through some of the important terms that you'll see in the process of making a PFX file. We'll get to that in a moment, what that is, and it's just generally useful. So check that out at your own will. Not necessary, but it is useful if you want some further reading, I suppose. Okay, so how do we actually go about adding in some visual effects to the game? Well, we use a .pfx file or particle effects file, and this is the main tool at your disposal. And each .pfx file contains one or more emitters, and each emitter is essentially one element. So as an example, think of a street light or street lamp. You have the light that illuminates the area around the lamp. That would be one emitter. Then you might want a glare effect around the actual light source. That would also be one emitter. And say it's a magical lamp and you want particles bubbling off the surface. This would also be one emitter. So in total, if we were to make this lamp, the PFX file would contain, therefore, 3 emitters. And you might be thinking, what does an emitter actually look like? Well, in the document here, you can see I provided an example. And here I've broken it down to what I deem to be 3 sensible parts. And these are the label, the particle spec, or spec for short, and the emitter properties. Now, the label is as it sounds, just what you label it as. I highly recommend labeling stuff. Say you've got a big file with 20 emitters in it, you're not going to know what everything is off the top of your head. And to be honest, even if you've just got one emitter in your file, it's best to label it, because you come back in 2 or 3 months, or someone else is coming to look at it, and they're not going to have a clue what it is at first without taking a bit of time to read through it. So it just speeds up the process and helps you out. So I highly recommend labeling it. And you can label it whatever you want. As for the spec or particle spec. This defines what the emitter will look like, in short, and it's contained within these brackets here. Then we have the emitter properties, which is the green box, and this defines how the actual particle will behave. So let's break it down and go into a bit more detail. We have, you can see I've labeled it light, pretty self-explanatory, hopefully, and then actually what it looks like. So I've said it's the shape of a point light. I'll break down this shape parameter later more. In fact, all of them. In this case, point light just means no mesh, no 3D mesh will be spawned, no particles will be spawned at all, so no 2D or 3D things will be spawned. It's purely just a light source. That's all this is. And then I've defined the color, which is obviously using the red, green, and blue values, and they're all equal to each other at 1, which is the max, well, not the max, but the 100% essentially can be as. So this is white. This is a white light, and I've actually increased the brightness by 400%. So that's what this is here. Then for the actual emission or emitter properties, we have emitter lifetime. So the emitter itself will last 1 second, and it will give a burst of 1. This burst will actually occur at 0 seconds, even if that makes sense. I'll go into this later in more detail, as I said, these parameters. 1 particle will spawn, and the lifetime will be 1. And then it will deactivate, basically. This means when the unit dies. And the size, I think this is diameter, I believe, is 50. Yeah, we'll go into more detail on that later on. And then the end distance is 1800. Now, just a quick note, you don't have to put everything down in your emitter. There are defaults, which we'll be going through now, or very shortly. And in this case, you'd think, oh, this particle's only, or this emitter is only going to last 1 second, because the particle's got a lifetime of 1 second, and the emitter's got a lifetime of 1 second. Well, there's actually some hidden defaults, which I haven't put here. So there's something called, it's in parentheses, lowercase b, uppercase L, OOP, so B loop, and that's true is the default, and that means that this will keep going on over and over again. So after the emitter dies or times out, so at 1 second, it will restart again, and so this will be a constant light essentially. Anyway, yeah, one thing also I'm quickly going to say is I like to organize my things in a specific order that I think is logical, so that's something that you'll also potentially want to think about. Anyway, before we go into the actual details of, particle spec or emitter properties, I'm actually going to quickly divert to the bottom of the document to where should you link PFX files. Now, in short, there's 2 places we can link it, and that is adding it to the unit.json and adding it to an anim tree. Now, the unit.json is basically I call it the control center. It's a bit of a silly word or way of putting it, but basically it's where you control all the variables or link all the variables for your unit. So like you link the mesh there, you link the textures there, you link the animations there, and the anim tree, you link the weapons there, you link the cost there, all this stuff. I'm sure if you've done any basic unit modding in this game, you'll have an understanding of that, but I just wanted to give a quick rundown for people that haven't. Anyway, so there's 2 places in the unit.json where you can link it, and that is in the events parameter and in the fx offsets parameter. Now, in events, this is basically like, think of this as like the life cycle of a unit. So when they're not all listed here, but build complete, so when the unit's built, when, in this case, this is an anti-aircraft cannon or flak turret, when it fires, there'll be an effect, and when it dies, there'll also be an effect. Now, here you can see that, in this case, we have the effect of default underscore muzzle underscore flash.pfx will spawn at the bones socket right muzzle and socket left muzzle. So this is this particular flak cannon or anti-air cannon has got two cannons. And so I want a muzzle flash to spawn on both of them when it fires. And also, when it dies, I have an effect here. Now here it's been a little bit different. It's actually, so I haven't listed a bone, so it will just default to the bone root. And in this case, it's just a default underscore building underscore explosion dot pfx. And I've actually changed the scale down to be half or 50% or 0.5. So hopefully that's clear. And then the other place, so FX offsets, we have, this is essentially, I suppose it ignores the event stage. You can see what it, instead of the life cycle, it's more what the unit is doing. So in this case, it's when the unit is idle, at bone underscore venting 01, there will be the core implosion device venting, which is, it's for one of the units I've made. This is basically just some smoke venting off the side from this bone. And you can see that you're actually allowed to do offset and orientational changes here. And this is in degrees, this is here. And this is in just the default units. So I can see it's spawning at 0, 0, 0, so there's no offset changes, and 0, 0, 0 orientation, so there's no orientation changes. So that's just, these can be handy sometimes when you want to do stuff. Yes, I also say note, if you want to add death and dead animations or effects, you want to animations also as well as effects, then you want to have in the unit.json has def effects true. Just a quick note there. Anyway, to the other one, we have anim trees, and this is relating to this. So in the anim tree, in this particular example I've given here, it's the living phase, so it's not being built or dying, but it's the final. I've named this. I have, so it's end, and it's going to play the end anim, which isn't going to loop, and at 0 seconds from when this starts, there will be core implosion device enabled end.pfx, and it'll be a default, well, it'll be a 1 effect scale, so 100%, so just normal, I suppose. And I've labeled it as extra particles and lightning, and it's attached to the bone. That's what this means. You can actually also do, offset. I think, do I have an example here? Let me just quickly head to my to find an example for you, because it's important that I actually show this. I should have possibly put it in the document. Implosion device. Let's go to the anim tree here. And by the way, this is Visual Studio Code. Highly recommend using it. So much better than anything else. Let me just find. Here we go. So here you go. You can see actually here. Let me just get rid of this. Here's another one. So this is in the. You can see here. We have several. We have being built. Nodes just is basically just defining the life cycle. So when the unit's being built, when the unit is stopped being built and is alive, when the unit is dead, and ghost just refers to when the unit is basically you scouted the unit. This is often for structures, to be honest, not really for units, as in like, you know, bots or vehicles or whatever. But ghost basically is what it will look like after you've scouted it but lost visual contact. So in this case, for this structure, it will just return to its bind pose, and in this case, this will infinitely loop on that. Now back to where we were. We have here, yeah, so we have the event. So in this case, I'm not going to run through how anim trees work, but we have at this particular animation, so or sequence, which is the loop, which plays animation loop, which is going to, as you can see, loop true until some parameter is set. At 22 seconds, we'll have at bone clamp some arcing, and it's got the bone orientation here. Notice it is different the way it's not labeled orientation like it is in the unit.json. And it's attached to the bone, but this time I've changed the offset slightly. So you can hopefully you'll have to play around and work with this. I will actually hopefully be going through some stuff to help you with this in a moment or later when we talk about offsets and stuff. But yes, so you can just see there. That's the example. Hopefully that's clear. Yeah. So let's just go over the. Now we've done that, let's go over the important actual parameters So we have here label, gone through that. I say it's optional, highly recommend, but now we have a big section, particle specification, or spec for short. Let's go through the first one here, shader. I actually say I'll go through all common, I say I'll go through all the common parameters, which I'm going to do. We have shader. The shader is important. It defines how the particle will look. So in short, if you have a 2D sprite or image or texture, you're going to want to use particle as your prefix. If it's a 3D mesh, you're going to want to use mesh particle. And then there's various suffixes, so the bits at the end, which add various characteristics. Now, just to say, there's a complete list in particle.json and the other document. I think the other document goes through more. It might not go through all of them, but there is a complete list in particle.json for sure, and you can find that in PA. If you go to your where PA is installed in Steam or Steam apps or something like that, click on it, go to media. I think I can actually just do it right now, to be honest. Yep. So here we go. So here's where my game is installed. So you open up the game media, PA, and then if you just do, or even just do it from, I'd probably just do it from here even. Just search for whatever it was called, particle.json, and you should find it. It should automatically find it for you within that location. Okay. So what do they actually do? What the common ones I've got here? Adds the color to the scene. A common one I actually like to use is the next, which is transparent. So it's the color of the particle, but you can also now use alpha. So earlier on I said that alpha can mean brightness, for, in this case it actually means transparency. So yeah, you can control how transparent the particle is. Soft, just particles blend with the scene, no hard edges. And clip, hard edges, and let me go through them here. Lit, we got works like soft particles, but also receives light from the ambient light and sunlight. So there you go. There's some of them, not all of them, but there's some of the key ones. Then we have another key thing, the shape. Now this is used to define the shape of the particle. So in this case, we have string, beam, mesh, and point light. This is an extensive list. I think this is the only place where I don't have an extensive list in this document. Anyway, so here, particles for string. Particles render as a string to connect to each other and back to the emitter. So basically, this is commonly used in smoke trails. So basically, yeah, that's the common use of it. A rocket, you want smoke to follow it and look connected, you'd use this. A beam is similar to string, but connected to a fixed point in the world space, and all particles are spawned at once. This is just basically used for the ion cannon, I believe, by the used by the beam weapon, basically, is the common use for it. Then we have mesh, so this is using a mesh instead of an image or a sprite. And then we have point light, which I went through earlier on, which is just basically you have no particle spawning, you only have a light source. So that's basically what that is. Okay, then we have facing. So this defines the orientation that the particle will face. Now, this can be a little bit complicated depending on what you want to do. So I'll just go through two of them. I'll go through all of them, but the first one, camera. This basically just defines the particle will always face the camera. And then we have, I'm just going to skip these two. We have velocity. The particle will always face the direction of movement. So that can be useful, I don't know, for a weapon or something, or but these two here, we have axial and XYZ or Z, and we have emitter XYZ. And this can actually be quite complicated. So basically, I presume you all understand there are three axes of orientation, and these being X, Y, and Z. And here I've got an example I've just spawned in. You can see these are running from positive in a positive direction. So we've got positive X in this direction, positive Y in this direction, and positive in Z in this direction, and you can see it in 3D space. It does move around. Now, just a quick side dump. This is the effect testing mod by Ferretmaster. I highly recommend it. It has limitations, but it is useful for certain applications. So here you can you link up here just where your effect is. It's going to have to be /PA somewhere within the PA repository. And then you can actually choose previous effects, and then you can even, if you want to, spawn in units. I'm not doing that. And you can change the bone if there is multiple bones it's attached to. If you know about units and bones and animations and rigging, then you'll understand that. And you can offset it. And this just basically means, if I do this, there we go. It's moved slightly. But if I do this, it's now back over here. And you can see that was in the X axis, so it moved 10 units, just default units, this way. And there's some other things you can play with, but that's to do in your own time. Now, what I actually want to show you was this, and for now we'll just stay on the bottom row here. So as you can see, I've got axial XYZ and emitter XYZ. This is axial XYZ here and emitter XYZ here, in case it's not clear. And just looking at it, you can see that the big ones that are being emitted less frequently, these are meshes, and the little ones are actually 2D sprites or images. Now, it can be a bit confusing, which is why I've done this. So here you can see that the 2D images and the 3D meshes are actually when no rotation, the top is when rotation is applied, so we'll ignore those for now. But when no rotation is applied, you can see when you use axial XYZ, they actually follow the orientation of the axes. And for meshes, the same works again for emitters. But when you use, at least in this example, a 2D sprite, you can see they actually stay in a static orientation, but they follow. They're still following. I've got some movement, so they're following the axes. Now, when you add a rotation to these, now I've added rotation to both the 2D and the 3D mesh. No change really to the 2D, but to the 3D, you can see that here, I'm going to start with the emitter this time, they're actually rotating around the axes. And I find this much more useful myself than the axial. Now, you might want to do this. It depends what you want to do. An example that I have done is, for my mod, is using for a torpedo to rotate around its axis. I've used this here. You might want a rocket to rotate around its axis, for example, to make it look like it's got a bit of spin, because often rockets do rotate. And this is just, a good way of seeing visually what you can how they work in a simple way, because often it's quite confusing to remember this off the top of your head. Sorry, apologies for that. Now I'm just going to quickly mention one other thing. Often if you rotate a bone, it can get a little bit confusing, so I will be releasing this and the other one I linked. And what you can do is actually go to your unit you want to, and you can actually link this emitter and copy it, or just copy the PFX to the bone, and that way it'll help you learn the orientation. But that's something else. I'll put those in the I'll either put that in the unit, not in the unit, I'll either put that in the description below, or you can actually find it on the Discord, which I've talked about earlier on, which should be in the tutorials and documentation channel. Okay, so hopefully that's explained facing for you. Now you can also do flipbooks. So essentially, you know what a flipbook is. It's typically used for 2D elements, I believe. You might be able to use it for 3D as well. And basically, a flipbook is just a series of images that will replace one another. And these are some parameters that control them. So you can have a random start, so it starts randomly, so it doesn't always start from the beginning. and you define the columns and rows, which is obviously important. And if for some reason there's an odd number, then you can choose how many to define how many frames there are in it. By default, it will just calculate it. Say if you did like, for example, if you did a flipbook, in fact, I say here, if you're doing a flipbook with 5 and you chose them to say it's 1 column and 5 rows, so it's just a vertical line, then you wouldn't need to do this because I'll just say the computer or the software, the game, would understand that there's 5 because you said there's 5 rows and 1 column. But for some reason, if you chose to do let's say you do 2 rows and 3 columns, now it thinks there's 6. But the last one's just a empty space. So this is when you'd want to define that there's 5. Now we have another important one. We have dataChannelFormat, and this is just defines the data format for the particles. And essentially, these are kind of cumulative the way I've ordered them. So position, particles send position and size and rotation data. Color and alpha data will be ignored. Then we have position with alpha, so now we have the alpha data. Now we have and color, so we have alpha and the color. And then if you want to use a flipbook, you need to use position, color, and flipbook. And then you can also use position, color, and align vector for flipbooks, but it also has some other stuff, including I think ramp color is also included. And I'll just if you want to find out about ramp textures or ramp colors, I recommend going to that other document I talked about earlier on. Okay, so now we have size. This actually appears, or rather sizeX, size Y appears in the Emitter Properties section, so I will go over it again there. Now, as you can imagine, size is about changing or defining the size of an emitter particle. And it gets a bit confusing when you have a 3D and a 2D particle because it works differently. Or I say it works differently, but in a moment you'll understand. If you use size X on its own, this is in the case of a 2D image, then it will control both the axes, the X and Y. If you want a different Y proportion to the X, then you would have to use size Y as well for the image, for the 2D image. Now, in the case of a 3D mesh, if you use size X, it will control 2 of the axes. Presumably X and Y, I don't know. It'll control 2 though. And size Y would control the 3rd. A bit confusing, not entirely sure why they did that, but just something to be aware of. And then we have use a random direction, which is default to false. And this just defines if velocity facing particles should use a random direction for their facing instead of the velocity direction. Okay, so now we have some particle color parameters. And you'll note I'm spelling it what I deem to be the correct way. And this is there's a few ways you could do it. There is the first one I've got here, which is red, green, blue, and alpha. So you'd have a red like this is an example, and you'd also have a green, which is similar to this, and a blue, and maybe an alpha. And you can see that just works as you'd expect it to be. So in this case, for the red that I've listed, it changes over time. So at 0 in its lifetime, it's at 10, which is oversaturation. That's like, what's that? 10,000? No, not 10,000. 1,000% that would be, sorry. And then we have at 0.2 in its lifetime, we have 200%, and then at 1, so when it's reached the end of its lifetime, it's at 100%. Now, the reason I'm saying lifetime and not seconds is because it's more, it's not confusing, but it could be confusing. So basically, I'll scroll up here. Here's a simpler. This is also a simpler way up here. We have the red, green, and blue. Just this is that. So that's going to be static, no changes. But I say the lifetime here is 1 second. So in this example here, these actually would correlate to time. But this is slightly confusing. So if it's 2 seconds, this would be 1 times 2. So think of it as a multiplier, I would. So at 1 second, at 1 times 2, so at 2 seconds, it's at 100%. And this would be at at 0.2 of 2 seconds, so that would be 0.4. We have, a value of 2 red. So that's just something to be aware of. You'll see this similarly set up. That's what this means, basically, because there's other forms which are more complex, which use displays like this. Now we have here an even more well, I don't want to say even more complicated, but it is potentially more complicated. We have more parameters. So this is RGB, similar to this, but in a way I actually find it's more useful. You can be more versatile with it. So instead of 0 to 1 and then +1 being oversaturation, we have 0 to 255. So these I've listed here aren't actually in the files themselves. I've just put them on the image. So we have time, brightness, red, green, blue, and transparency. So hopefully those are all clear. Transparency, whether it's see-through or not, these are the colors. Time, obviously understanding, and then brightness. So in this case, at the beginning of its life cycle, it is at 100% brightness, and at the end, it will be at 0% brightness. And this will just be a linear fade to it, to 0 brightness. Okay, and as I said, there are ramp textures, so I think I haven't got them in the document because I don't actually use them that much. But you can find, if you just look ramp in the document, you'll see ramp here. This is another way of defining colors, and you can see they talk about it there. Here's some other parameters. And if you want to look into ramp textures, as I said, I rarely use them. Then you can look at the other document for that, or the base game for the files. Just use Visual Studio Code. You can actually search. Anyway, so onto another. We have use army color, and this is pretty obvious. You can make it either use primary or secondary team colors instead of a texture color. Okay, so that's pretty much a summary of particle spec and the common components of it. Let's move on to emitter properties. So as I said, in short, this is how a particle behaves. And as I say, a note of advice, many emitter properties have defaults. If you want to keep the defaults, you do not need to add them to the emitter. In fact, it's probably beneficial to not add them to make it less complicated. Sometimes you might want to add the default just to remind yourself. If it's something like, for example, B loop, which we'll go through later, which, as I said, tells the game to repeat the emitter, then maybe that is one that you want to put there just to remind yourself that it is repeating. But anyway, let's go through the common parameters. So, an important one here, type. This refers to the shape that the particles will spawn in, so a cube or sphere, for example, and is used in combination with offset, which essentially you can imagine as warping the shape in certain dimensions. Actually, this should say offset range. Ignore that. I will change that. Offset range it is. Let me highlight this in red. That is wrong. It should be offset range. There we go. Ignore that. Let's put a strike for you as well. I'll change this for the final document. Don't worry. Okay, so we have position first of all. So this is just a cuboid. It's the most simple. It's just a square, and basically particles will spawn on the surface and in the volume space of that cuboid. Then we have spheroid, same thing, just a sphere. Then we have cylinders in different axes, because obviously these are no longer, they can be different depending on the axes you want them in. So we have X, Y, and Z. So this means it will run along or around the X-axis, and this will around the Y, and this around the Z. And again, particles spawn on the surface and in the volume space. Hopefully you know your shapes at this point in your life to know what those are. Then we have mesh. So this is when you want to add a custom mesh. And again, particles spawn on the surface and in the volume space. Now we have a box, and you might be thinking, well, why is there another box here? Because we already have position, which is a cuboid. Well, this is if you want to have particles only spawning on the surface, and it's pretty useful for that. So in this case, it's an open-ended box, and the axis defines which axes that is on, and particles will only spawn on the surface. Really useful. Okay, now we have shell, same as spheroid, just this time only spawning on the surface, and we have also emitter, and it's a cuboid that's essentially the same as position but linked to another emitter. So basically you have to use link index, which I'll go through later on. It's at the bottom, and basically you link this emitter to another. So I'll just quickly jump to let's go to let's open up one here. Let's open up and give it a nice showing of VSC. So often when you import from the base game there in this format, VSC is useful. You can just right click, format document, lovely, bish bash bosh, in a nice way to read. So imagine this is, I'll just rename it for now, this is a piece of debris for this explosion. There's actually already one called debris. Anyway, this is, we'll call this smoke trail. I can make those capital. Imagine I'm making my own. Now, I want the smoke to follow the debris, and this might be flying off in different random directions. Now, what I would do is I'd come down here and I would just do, well, first of all, I would change that to emitter, and then I would go, let's just move that along, link index 0. Now, you might be thinking, whoa, hang on, why is it 0? That's because basically it runs in numerical order, but the first is 0. So this would be emitter 0, this would be emitter 1, and then this would be emitter 2, and so on and so forth. So hopefully that's clear. And let's go back to the document. Yeah, so that's basically what that's for. Useful for smoke trails, as I say. Can be used for other things as well, obviously. Anyway, here, this is the correct thing. At least I've got this right. We have, for all of these, offset range X, Y, and Z controls the dimensions. So you can think of it as stretching. Let's think of a sphere. You can think of it as, or any of them, it stretches them in the X axes if you increase the range, and the Y axes and the Z axes. And then offset, and this is the same for everything if you use offset, just changes the position that it spawns in, that the central position spawns in. Okay. Right, now let's move on to position and orientation related parameters for emitters or emission properties. I was just talking about offset. We have offset XYZ and we have offset range XYZ. Now it's pretty simple as it sounds. If you type in 5x or 5 for offset x, it will move 5 to the right, or 5 in the positive x-axis rather. And offset range is similar. It just means it can spawn either side of that point that you've changed it to. So here's a nice visual demonstration. This will be useful for all the ranges, which we'll be going into. So if I'd said offset x was 0.5, this is obviously, you can have this as, imagine this could be any scale. I've just chosen it to go from 1 to 1 and 1 to 1. If I change offset x to 0.5, and then I have, well, if I change it to 0.5, then particles would spawn here if I didn't have offset x range, and only spawn here. But if I add offset range x and change that to 0.25, that means that particles can spawn from anywhere from 0.25 to 0.75, so this whole purple area. So hopefully that's clear. Then we have snap to surface. Basically this means that particles will snap to the surface of the planet. I think the only place I've really seen this is in explosions, like think of it, the nuclear explosion, for example, where there's a trail of smoke running along the ground outwards. That's I think the only place I've seen this used, but it can be useful. Maybe you want some sort of weapon that fires along the ground and follows the curvature of the planet. That could be quite useful. Then we have an offset. This just basically increases the vertical height of it from the planet surface. Align velocity to surface. Yep. So hopefully that's self-explanatory as well. Then we have the rotation. Now rotation just means this is static. This isn't rotation rate. So rotation just means when the particle spawns, it will spawn with, if I change this to 90 instead of the default 0, it will spawn at a 90-degree angle. I believe, hang on, oh wait, this might be radians. Yes, sorry, this is slightly confusing. This is actually not in degrees, this is in radians. So 360 degrees is 6.3 radians. So I guess if I wanted it to be 90 degrees, I would just divide it by 25% because that's is that correct? I think that's correct. Maybe I'm wrong. No, I don't. No, sorry. I mean, 6.3 times 0.25 is what I actually mean. So I'm multiplying it by 25%, and that means I'd want it at 1.57 or 1.58 if you wanted to round up. If I always wanted it to spawn at 90 degrees. So just be aware that rotation is always in radians. Slightly confusing. Don't know why they didn't use degrees. I think that's probably most people find that easier, but maybe there's an actual reason why they did radians. If you know, you can tell me in the description or in the comments even. And then we have rotation range. So this again works similarly to this. It means that if I set this to 90 and then set this to 90, that means it could spawn from anywhere from 0 to 180. And sorry, if I set this from whatever the value I said was the equivalent of 90 degrees. But you know, I might speak in degrees from time to time if I'm not paying attention. Sorry. Anyways, hopefully that's clear. Then we have size, random flip x and y, and this basically means that the particle, if you set to true for x, for example, it would flip. If the particle was this way, it would flip backwards and forwards and mirror. Just so you know, and that's random. And this can also be used with flipbooks as well, by the way. It's not just only for static particles. Okay, now we have the size-related parameters. Now, similar to the particle spec section, we have sizeX and sizeY, and it behaves in exactly the same way here. However, one thing I will point out is that if you have sizeX and sizeY in both the particle spec section and the emitter properties section, the sizeX and sizeY in the particle spec section will take precedent. It will override the sizeX and sizeY parameters in the emitter properties section. Now, I'll just go through this quickly again, just in case anyone skipped through to this section. Basically, as I say, it defines the size of an emitter particle on the respective axes. However, if you use sizeX on its own, it will actually define the size in all axes. So you could use that to change the size there. However, if you do use sizeY for a 2D image as well as sizeX, then obviously X would control the width of the image and sizeY would control the height. Slightly confusing for 3D meshes though. SizeX controls 2 axes and sizeY controls the third. Don't know why they didn't do a size Z, but they didn't, so that's where we are. And I'll just quickly go through again what I did earlier on. So if you've just got sizeX like I have here, just for clarification, stepped means it will be a linear smooth transition between the two stages. If I put this to true, then it would just go at 0 seconds it would be 20, and then as soon as it hits 1 second it would be size 1. Anyway, so yeah, this is sizeX is controlling all the axes because it's here on its own. So at 0% of its lifetime, in this case the lifetime is 1 second, so at 0% of 1 second it'll be size 20. And at 100% of its lifetime, which is 1 second, it will be size 1. So hopefully that's clear. And then we have a new thing here. We have size range and X and size range Y. This behaves exactly the same as the other range parameters. Then we have movement-related parameters. So we have velocity, and this defines the velocity of a particle. This is literally what controls the speed. You could set velocity XYZ to 100, 50, 1,000, a million. It is not going to change the speed. Unless... no, I think that, yeah, it won't change the speed. So this controls the speed, and that's the distance in or units. 1 unit. A particle will travel 1 unit of distance per second, basically, is what you need to think, if set to 1. Okay, so velocity x, y, and z. Now, this is slightly confusing, but it's not that confusing. So if I set velocity x to 1 and then others to 0, or didn't even put them, because by default they are 0, then it would move, as long as this is also set to 1, in the x-axis from its spawn, in 1 unit distance per second. Now, if I say I set y to also 1, I'm not going to change z, but if I set x and y to 1 each, now I say it's cumulative. It's a cumulative effect. So basically what I mean by that is, if I go back into the game, if I've got x set to 1 and y, it's actually going to move in between the two. In a perfectly between the two at a 45-degree angle in this case. Just going up here, it'd be going. So hopefully that's clear. And you can use this in creative ways if you wanted to go in like you could work out the maths of like I don't know, a certain angle you wanted if you wanted it to do something like that. But you can do that. Anyway, then we have velocity range. You can guess what that means. You can just choose the velocity range to be random. So if this was 10, you could have this set as 5, and then it would either go from 5 to 15, if that makes sense. Or if if there's 20 and have this as 5, then it would go from 15 to 25. And then again, velocity range XYZ just controls how much the angle of it is being influenced, or the velocity. Now we have acceleration. Pretty self-explanatory. Rotation rate. Now this is a continual rotation. So again, radians per second is what it's in, not degrees. Take note of that. Rotation range or rate range. This just changes the potential for it to have different rotation rates, the particles, if multiple are being spawned. Inherited velocity. I never ever use this, to be honest, but I put it here. It adds the system's velocity multiplied by this value to the initial particle velocity. Sounds quite confusing, and in a way it probably isn't, but yeah, it's rarely used. You can delve into that yourself and see how it works. Yeah, I rarely ever use this myself. And then we have use radial velocity direction. And basically this uses the starting location as a normalized vector in addition to the velocity direction values. That sounds very confusing. Basically, think of an explosion. There's lots of random debris going in different directions. You want to set this to true then. So as I say, it's commonly used for debris flying in random directions. That's basically all you need to think of. Now we have shape velocity, so using the starting position on the shape. So earlier on we talked about up here the shape, I believe, up here somewhere. Where was it? I can't remember. Well, you can scroll up and find out where it is. Basically, use the starting position on the shape from the emitter's type in addition to the velocity direction. And the type refers to what we talked about in this section, which is the spheroid or mesh or whatever. Where was I? I have lost myself. It was down here, wasn't it? Yes, okay, so then here's a really important one. Use world space. So basically, by default, it's set to false. But if you set it to true, it means the particle will become detached from the emitter. And what do I mean by that? So here's an example. You have a gun turret. We'll say it's a cannon of some kind. And you fire it, or it fires at a unit of its own accord. And then it starts to rotate to fire at another unit. Let's say it's behind it or just somewhere else. If you kept this as false, say there was a puff of smoke coming out at the end of the barrel, that would remain attached to the end of the barrel and look like it's following it, which would look dumb, to be honest. It wouldn't make sense. So if you'd want to set this to true, and then say it fires, and then it starts to rotate, the smoke would remain in the orientation and position that it started in, if that makes sense. Or the axes of travel, if you applied velocity to it, which you likely have. So yes, this is important. Now we have another one, offset allow negative Z or Z, depending on pronunciation. Basically, I've only really seen this for explosion effects, as I say, and most of the time it's set to true. So for explosions, it's often set to false if it's a ground-based explosion. So basically, if you have an explosion, you don't need stuff to be rendered going into the ground, like random bits of debris flying off. So only go in a positive direction away from the surface, or upwards from the surface. So you set this to false, and it will prevent any particles being spawned down. Also, it just kind of doesn't make any sense for particles to be spawned down, not because you're not going to see them necessarily, but also because when there's an explosion, the ground stops them from going into the ground, so you don't need that effect anyway. So it's just something to note of. Then we have gravity and drag, or air resistance. So gravity accelerates particles either towards or away from the planet, depending on what value you use here. I actually probably will add by the time we get to there to release. I'll put a note to highlight this in yellow actually. Which is which? I can't remember off the top of my head. It might be a positive value. In fact, you know what? Let's check right now. We have this document here. Let's take a look. I'm guessing, as I got negative 9.8 here, that's probably meaning towards the planet's surface. Let's double check. I mean, this is the handiness of this document. So I should really thank, again, Dom and Mikey and Ben for this handy document. Does he say? I don't know if he does. He doesn't. I will check. I will check which way is which. I will do. Maybe I'll put an annotation here, but it will certainly, I'll add it into the document. I will do. I'm guessing it's probably a negative value is towards the planet and a positive value would be away, off the top of my head. But I'll add that in for clarity. Anyway, drag, so it defines a multiplier used to either slow or speed up particles. A value of 1 will mean the particle will continue with no slow or speeding effect. Values over 1 will accelerate the particle. Values below 1 will slow the particle. And I say, note, confusingly, a value of 0 will turn off drag altogether. I suppose the creators of the game were thinking, well, if you've got no drag, what's the point of having the drag anyway? I suppose. So yeah. Then we have time and emission related parameters. Apologies. So here we have delay, and this is for each emitter. So this defines the time in seconds that the effect will be delayed. Or rather, this particular emitter, because you can put one of these for each emitter. This is all relating to individual emitters. If I haven't made that clear, hopefully I have. Delay range, same as anything. That's the other ranges. You could just make it like, so if I put this as like 5 seconds and then had a delay range of 1, then it would spawn between 4 and 6 seconds. Emitter lifetime defines the time an emitter will be active in seconds. Emission rate defines the rate of particle emission per second. So you'd have 20 particles spawning over a linear time. So this is linear, so equal time is the default. 20 is, sorry. So that over this, if it was a 1 second lifetime, you'd have 20 spawning in that time period, basically. Now, emission bursts, if you leave it as just the simple form, so emission bursts, then a number, so not 1 or 2, then those would happen both at 0 seconds in its simple form. But if you go for the more complex form, which is this one here, which I've given the figure for, then you can see at 0 seconds, I've actually said in this case there's going to be 3 plus or minus 2, and there's a 100% chance. And I think you can actually add other, so I could put a comma here and I could copy this and copy it below, and then I could have like change the time to like 10 seconds or 15, and then make this like 15 seconds, as in addition to this would be 15 seconds. There will also be another one with a 100% chance of, we'll just say the same again, 3 and plus or minus 2 particles being spawned. But yeah, just remember by default, if you just leave it as the simple form, it is going to spawn at 0 seconds. That's basically what I wanted to say. Another important one here, we have max particles. So default, no limit, unless you're using emission burst, then it defaults to 0. So just remember that. Particle lifetime, this is default is 1. Defines the lifetime in seconds that particles will be that particles emitted by the emitter will be alive, essentially. And I would say if set to -1, the particle will never despawn. That's also something important to note. And I say it's unaffected by emitter lifetime. So what do I mean by that? I say you have an emitter lifetime of 1 second, and you have a particle or lifetime set to, so just lifetime, set to 20 seconds. If the emitter stops, the particle will continue for another, well, I guess it depends. If it spawned at the very beginning, it'd be another 19 seconds after that emitter has died, or you know, whatever. Lifetime range, explanatory. B loop, default is true. Take note of this. Basically, it defines if the emitter will loop or not. You are gonna probably want to change this for some things. Sometimes I tend to define this even if it's set to true, just to remind myself. I said earlier on about that. Loop count, start loop, end loop, these are all relating to the loop factors, and you can read through them a bit more here. So loop count, pretty self-explanatory, it's the number of loops, start loop and end loop there. We have kill on deactivate. So this is so it can be set to true or false, and it defines if particles are immediately killed upon the emitter being terminated. And basically what this means is if the unit dies, if the kill on deactivate is set to true, the particles will immediately dissipate. Immediately. There will be no time. It won't be like, it will ignore the lifetime. Say like the unit spawned in and the particle's got a lifetime of 100 seconds, and then the unit dies before that 100 seconds is up. The particles will disappear immediately if this is set to true. And then we have some other parameters. These are, so I mentioned link index already earlier on. So we have start distance, and this is just disables the emitter particle when the camera is closer than the defined distance, and we have end distance, which disables the emitter particle when the camera is further than the defined distance. Pretty obvious. Another important thing, if this is set to -1, the particle will always be visible. That's a useful thing to know. I do often leave helpful, handy notes and stuff, so look out for those if you're reading the document. I know we have the link index, as I said earlier on. It must be used with type emitter, and it's just useful for linking different emitters together. Okay, so that is essentially the document. I'll just say a quick thank you to Ferretmaster for his help in clarifying certain terms. By the time I have released or made this video, I'll actually probably put a link in here for the video. You're obviously watching it now, so you're not going to need it, but that will be there. Yeah, but that's the end of the documentation section. So now let's head over to making our own visual effects ourselves. Okay, just a quick editor's note. If you do want to use any of the PFX or visual effects you've seen in the previous section, so the axial orientation visual effects, so emitter XYZ, axial XYZ stuff, or the, probably most importantly, just the simple X, Y, and Z, if you want to try and coordinate which way the bone is orientating, then, or in fact any of the effects you're about to see now, the .pfx, then what you can do is go to Community Mods on the main menu, head to Available, and you should see Visual Effects XYZ guide here. If you don't see it, maybe it's multiple mods updated, just type in visual or effects. Maybe visual's a better one because it will isolate it more. And you can just download it here. Okay, now back to the rest of the video. Okay, so here we are. I'm in Planetary Annihilation Titans, and I'm just going to spawn in the example effect that we're going to be making. Here's one I made earlier, as they used to say on a art attack or whatever thing. So here you go. We'll just examine the different elements. So we have two meshes here. We have a ring mesh and a ball. Now it's a bit hard to see because of the because they are just one color. But you should be able to see from me changing the orientation. I'll show you them in Blender in a moment. So that's one or two. That's two emitters. We have the ball and the ring. Then we have the glare. That is another emitter. And then we have the particles as well. That's another emitter. And then we also have the point light, which is doing the flashing, which you can see is illuminating the terrain and also the units. So I'll just quickly go into Blender. And as you can see here, I have got the meshes, so you can just see these are the actual things we're going to be playing with, and these will be spawned in. But let's head over to Visual Studio Code. So here I'll be going through them as I said. So first of all, we'll go through the mesh. I'll actually only go through one of them because I will show you the other one. But I won't go in that much detail because it's literally just changing the mesh itself. Then we have the glare, or as I'm calling it here, the external eclipse, because that's the name of the image. Then we have the light pulse, which is the point light, which is doing the surrounding illumination of the area. And then we have the particles themselves. So let's begin. Let's start with the mesh. So I think I say before to a good way of doing your own effects is to take something from the base game and adapt it. That is what I would do. That's what I have done, and it's just useful. At least for getting started with, until you know how to just do your own, and it's always useful. So let's start here. So first of all, I've labeled it Disco Ball Planet. I think that explains what it is. It's just the sphere. I mean, I could just name this Disco Ball Sphere as well, but I'm going to keep it as Planet for now. I mean, actually, you know what? Let's just change it to Disco Ball Sphere. We'll call you Sphere. Disco Ball Sphere. I mean, technically a ball is a sphere, so let's just call it Disco Sphere. Anyway, it's a mesh, so I need to identify it as shape mesh. Remember earlier on in the video, I went through the various shapes. We can go back to that now. I can go here and just do shape quickly. We have all these other ones. I want to use a mesh, so it's going to be a mesh. Now, as I said in the shaders, I want it to be a mesh particle as opposed to just a particle. And I quite like using underscore transparent because it allows you, if you want to play with the transparency values. Now, earlier on, you saw in the we have facing emitter Z. We do as well. Now, earlier on, I talked about colors, and this is the slightly more complex one. So you can remember this is time. The first one is these are all changing colors. So we have the time, the brightness, and the brightness is staying consistent, as you can see. Another great tool of VSC is that when you highlight something, it highlights similar things. And you can see it's changing in a linear fashion colors every 0.25 seconds. So it goes from orange, and also you can see the transparency stays at maximum opacity. So it's you can't see through it. That is at 255. So you can see though that the colors are changing from, I think this is orange to a blue to pink to a darker blue. I think that's what it is, and then back to orange is I think the way I've got it. So yes, I think that is clear. I think that works well. I could be wrong. So essentially, yeah, that's that. And then I have the actual mesh itself. So here I've got the Papa, as it is. and this is going to link to sphere ICO 16 segments, which is this here. It's not labeled it in here, but that's just the name of it in here. It doesn't make a difference. So that's that. And then the texture I've gone for, this texture here, this flat.papa, it's just a flat 1x1 pixel. And actually one thing I can do is if I go to the base game file, so here you can see these are the base game. This is where you will find the sphere. We can also go and take a look at the textures. Now I have extracted them using some software. If you want to extract them yourself, I recommend asking in the modding channel or asking me in my Discord, or Luther particular, another person in my Discord, or you can ask one of us in the PA Discord if you don't want to join. So here, for example, is the eclipse texture that we'll be using later. And I believe, yeah, here we go. Here's the flat. So this is the 1x1 pixel. Okay. So you can just go through here in your own time and look at various things, or if you're making a mod, then you'll add your own or whatever. Anyway, so that's that. So you can see that the emitter has a lifetime of 1 second, and I've changed it to emission rate 1000, so it's constantly going to be there. You're never going to see it not there, and there'll be one particle though at a time, and then the lifetime of the particle is 1 second. So hopefully that's clear. And then I've changed the sizes. Remember, this is a mesh, so this size X here is actually controlling 2 axes and size Y the third. But I could have just scaled this up in Blender, but that's a lot more effort than just changing it here. And then when the unit dies, it'll deactivate, and this will never ever go out of distance. So if I scroll out here, you can see it is always visible. In fact, you can see another one here. I mean, obviously there's a point where you just don't have enough pixels to display it, but it is always visible. Now if I go back to here, that hopefully has been explained. Now, as I said earlier on, that you don't always need to define something if you want the default. Now I haven't got here b loop true. I'll put a comma there so it doesn't break the code. The reason I haven't got b loop true here is because I know that this effect is that the default for that is always true. B loop, that is. I know that this effect is always going to loop. Maybe you will want to add that to remind yourself. I don't need to, so I'm actually going to remove that and keep it as it was. But that is something that you could do if you wanted to. Now we have the ring around the disco ball planet, as I'm calling it. And essentially it's exactly the same file. I'm just changing it to be shockwave teardrop, which is this file here. Yeah, so basically that's that. If you're wondering why it looks different in Blender from when you import it, that's because I've gone into the object data properties and clicked clear. I think there's like clear normals data, because I found that it defines the shape of it better. That's my personal opinion. Anyway, back to the document. Again, it's the same, so it's not going to disappear. Let's move on to the external eclipse. So this is adding a 2D sprite or image. Now we have, I'm using shader particle add soft because I want it to add in a way that is, I want the color, but I also want it to blend in so there's no hard edges. So that's why I've chosen this. And of course, you can play around as you wish, and you could have this as, I don't know, what's the other ones we got? We've got clip. You could have clip if you wanted to. It's up to you. I think soft is the one I want to use for this. I think probably is the one you'll want to use. Anyway, so the colors are the same because obviously it's important to have things linked together. I don't want it to have a different color to the planet or the ball, because that would be weird. It would look like they're disconnected. It might look better, maybe, I don't know, but I personally don't want that to happen. And here I've added a little bit of camera push. So I can't remember if this is actually going away or towards the camera, but you can play around with it yourself. And here you go. I've defined the eclipse image itself. And then we've got some emitter lifetime properties, emission rate. I've actually got it lower here. It's 600. We could probably have that at 1,000 if we wanted to. Just essentially, you need a high value, and one particle at a time, and it's changing. The lifetime of the particle is 0.25. So yes. So if we go back in game, we can see that it's a bit harder to see because it's daytime. So let me. Or I can actually, you know what, instead of speeding it up, I will just go onto the dark side of the planet. Here we go. So now we can see that it is changing color quite rapidly, and it's also changing position because I've changed it to 0.25. So hopefully that is okay. Here I have decided to put it as B loop true. And I've changed the size, and I've made it so the range of it can change, and there's also a bit of rotation range. So this is I've put it as half the value of this is actually like 180 degrees essentially. Maybe I should change this to 6.3. That's probably a better value. So I think we'll change that, and we can keep that. Maybe that's something you'll want to change as well. In the file you'll have, it should be this anyway, because I'll have saved it and send that now. Again, kill on deactivate. That means it's going to die when the unit dies. Sort, you can ignore that for now. That's nothing really important. That's also me partly saying that because I don't know. I just when I say it's good to copy stuff from the base game, I've just copied this parameter from a place where I also saw this. I'll pin in the description or in the video comment section if I find out what sort is, or maybe I'll have added it into the document. I just tend to leave it there. If I see something, you know, often if it's not broke, don't fix it, they say. So I've left it there. This is probably the only parameter, or one of the only parameters I haven't gone into detail on. I will double check though what this is. Then we have end distance again. Okay. Yep. And then we have light, the light pulse, so the actual flashing. So again, I've set the shape to a point light because in the document, as you saw earlier on, this means that no particles will spawn, no mesh will spawn. It's just going to be illuminating light, and I've copied the colors. Emitter lifetime is the same. I've changed the lifetime as well. And then we have emission rate 600, particles 1 though, so there'll be 1 at a time. Kill on deactivate, and there is an end distance here. And then that's the end of adding a light. Now for particles emitting off the surface. Now apologies if I'm going a bit quick here, but obviously you can stop and pause throughout, and you obviously have the file with you so you can examine it. Now here I'm using, again, one of my favorite ones. I like using transparency, and in fact we actually want this particle to become transparent as its life goes on. So I've got particle transparent as the shader, and this time you don't necessarily need, you could, if you want to, change this to camera, and I think that would work fine, but I've got it facing velocity, and you should be able to see the difference in some of the particles. They will be facing the velocity. But camera actually might end up being better, to be honest. But for this demonstration, it's acceptable. So I've got the size here set as 1. I'm not actually sure if I need to keep that as 1. I could probably remove that, but I'm keeping it there. As I said, If it's not broke, don't fix it. You can obviously remove that if you want to. Again, similar RGB color values. However, there is a difference this time. At the end, so what I've done is I've added this in because in the last few, I don't know, what is this point? What is that? I don't even know what that is. It's like a point. It's a fraction of the lifetime. I wanted to go from fully transparent to not transparent. Sorry, I said that I said that the wrong way around. I wanted to go from fully opaque to fully transparent. So that's what I've done here. And as you can see here, we've changed it to soft.papa, which is, I think I can find that for you so you can see what it looks like. Soft dot, here we go. So here you go, it's just simply a dot with soft edges. Close that please, thank you very much. No, not you, you. Okay. Yes, so here we are. Now, I've changed it to type shell. Now, you might remember earlier on that I said type shell was a sphere, but particles only spawn on the surface. And what controls the size is the offset range. So these are the, I think this is probably the radius. So this is the radius in each direction. So it'll be 5.25 to the right, or positive x-axis, and also 5.25 in the negative axis. You obviously understand how ranges work because we described it earlier on. If you are slightly confused, just go back up or back to this image here. It explains it nicely. Anyway, so that's that. And this time we have the emitter as a lifetime of 0.25 seconds. That is. So every quarter of a second, 160 particles will be emitted. So that means every second there'll be, what's that going to be? That'll be, it's like just under 8 so what's it going to be? Under 800, is it? I think it'll be, let's get a calculator out because I can't be bothered to do the maths in my head. 640 every second. So yeah. And then we have the lifetime as 2 seconds. So each of these particles that's emitted will last 2 seconds. And then we have the size of the particles actually being reduced. So it's 0.75. And the range is 0.2. So that means the particles can actually be from I don't know what I say, 0.55 to 0.95. And it's using radial velocity because we want them going in random directions. And the velocity, the actual speed, will be 8 units of distance per second with a range of 0.4. So that means it can go from 7.6 to 8.4 in terms of the speed. It'll be random somewhere in between that, each particle will be. And the velocity range, I've just set 1 in each direction. So it's always going to be an equidistant position between the 3 of these points. So if you took your hand and made it into the typical shape everyone tells you to make, in fact we can just go back in game. So here you can see I am currently looking directly at the x-axis is this way, the y-axis is this way, and the z-axis is this way. So currently, if I come this way, I should hopefully get the perspective and not make it too difficult. It's actually, the particle will be emitting towards me. Just about, let me move more. There we go. It should be emitting, it'll be emitting towards me, it would be. Because it's in between, as we said earlier on, if it was just 1 and 1 for x and y respectively, it'd be coming down here. But there's also some verticality to it because we added the y-axis. Anyway, hopefully that's clear. Hopefully I'm not confusing you. As I said, just play around with it if it is. And then we have kill on deactivate. And then this time, again, like I mentioned earlier on, use world space equals true. So this means that if this was moving, so I think I can actually do, I don't know if I can, let me just check. Disco ball example, let me just delete that. I can't delete that one. So I'm going to use, I think it's Shift G. Yes, here you go. So because it's using world, you can see that the particles are not staying attached to the well, they're not remaining fixed in place. They are where they're spawning is where they start from, and they remain unattached. So they'll just go in the direction that they randomly spawned in. So I think that makes it fairly clear, hopefully. Anyway, there's that. We'll go back here. And then we have the end distance set as 800, because obviously we don't want it too high. These are smaller particles. When you scroll out, you're not going to see them. They're going to go out of visibility quite quickly, so we don't need to spawn them into, like, I don't know, 1,000 or indefinitely if we're going to set it to -1. So that wraps up all the different emitters, and you'll end up with something like this. Hopefully you now understand the basics of how to create visual effects using .pfx and can use this tutorial alongside the PDF I provided and the other documentation to create your own visual effects. Now, before I go, I'd just like to say a big thank you to my patrons, Dreadnought and Meal Solutions. You can join for as little as £1 a month, and it just really helps me out. Be sure to leave a comment if you need help, or join me in my Discord where you can ask further questions. Thanks so much for watching, and I'll catch you in the next video.